Good afternoon. My name is Garima and I'm from EV Mechanica. Welcome to Evolutionary Talks with EV Mechanica. And I'm here to interview Mr. Shubham Vishwakarma from Metastable Materials. Thank you for taking time out and doing this interview, sir. Thank you for being with us. We welcome you. And
Yeah, thank you for having me.
could you please give us a little brief about your company?
So, we are an expert in EV battery recycling. Well, actually, we are an expert in lithium-ion battery recycling. We started a couple of years back with an idea that the traditional EV recycling methods are a bit of like a waste management methods. We thought that if we can remodel this entire industry on principles of circular economy and urban mining, it would be better. Which essentially means that we are bringing the ideas and the methodologies that has been used in the mining industry for the recycling. Assume that you dug these batteries out of the ground. If you would have dug them out of the ground, how would you have extracted these metals out of it? That essentially make that every city is a mine for us, and we are that uh, these batteries do not go back into the ground so that we can mine them.
Okay, sir. So, what do you think were the primary challenges associated with recycling electric vehicle batteries?
So, any recycling industry, the job of a recycler is a pretty straightforward job. You have your material from which you want to extract and make sure that they do not go back to landfill. The first task is safe handling and reverse logistics of any material. Once you have a Coke bottle at your home, you want to make sure that it reaches somewhere to be processed. That remains the Achilles heel of whole recycling industry. You have a very distributed network of these materials that has to be concentrated into few factories. Reverse logistics essentially. Then comes a challenge of processing. Now, processing is somewhere that we expertise in right now. So, although I have a lot to talk about, but let me condense into these few things. You have a very complex product at one end, and what you want to make is a very complex product at another end, which means you want to make new batteries out of old batteries. The task is very challenging. If you try to make new Coca bottle out of old Coca bottle, the task is very challenging. What we are saying is that we will take these batteries, treat them like an ore of lithium, cobalt, and nickel, put these metals out and put them back into the individual supply chains, treating these batteries as a ore of it. And hence the technologies and the processes of ore processing has been worked. And this is the second part of it. What you're looking over there is pretty straightforward that you look into anything, which is yield, purity, process cost, and hence the challenges of a recycler. What you're producing are raw materials for the whole world. The time have this lithium, it's in the commodity form, the way you like it. Use it to make whatever you want, including lithium-ion batteries.
Okay, sir. So, how is the current and modern recycling method different from those that were used traditionally?
The traditional recycling methods can be essentially broken down into two methods. One is called hydrometallurgy, one is called pyrometallurgy. Hydro means water, pyro means fire. You crush these battery, you pre-process them, uh, which is called black mass, and you throw them into a giant furnace. Your heavy metals will melt and sink at bottom. Your light metal will go at the top. You throw the light metals away and you get your heavy metals, which is copper, cobalt, and nickel, mostly speaking. Ironically speaking, we don't recycle lithium out of lithium ion batteries using this method. You can see why nobody likes it. The second method is called hydrometallurgical method, which is I mean, anybody with a high school chemistry set can understand this method. So you take your batteries, you crush them and produce essentially black mass again. You pre-process it and start dissolving it. You dissolve it into a very strong acid or a plethora of acids, so that everything is converted into a solution. Now you start a small army of very weird chemicals, very select specialized chemicals to pull each atoms out. So if you want lithium, you get something that only bonds with lithium to get it out. If you want cobalt, to send something that only bonds with or on those conditions with cobalt to get it out. And it's a battle against impurities essentially. So these are your two methods. This is how traditionally batteries has been recycled. Most of the batteries that are recycled today are recycled using hydrometallurgical methods. Very easy to design, but it's a very difficult process to industrialize. What we are proposing is that instead of using these two methods, we will use the traditional mineral beneficiation technologies. So the right technical term for what we do is mineral beneficiation. But I know you need a 4-year engineering degree to understand what it means essentially. uh, so mineral beneficiation process are the process by which we have broken down entire mountains. It is when you have an entire mountain, you have like 1 or 2% of stuff that you want in it. You use these kind of processes. It's essentially breaking and separating. You break things and you see what I want out of it and select it using it. Density separation, size classification, solubility, magnetic separation. These are your traditional mineral beneficiation processes. Out of this 500-ton material, I have a couple of tons of iron, which is magnetic. I'll use magnetic separation. Everything's break differently, so I'll selectively select the sizes I want to go from like 1% to something like 20%, then you go to like 60%. And hence we are using mineral beneficiation processes. These are difficult to design. They largely don't work at small scale. They need industrial scale even to be tested and designed. And you are working with a lot of contamination and weird problems of industrial scaling in the beginning only. So, but we have been lucky and we have been courageous enough to try this method. And right now we are at the phase where most of the science has been figured out, most of the engineering is done, and now moving into the commercial deployment of the technology. It's not one single technology, as you can understand. It's a solution to a problem. How do we have a better recycling process? How do we not use traditional chemical processes? The byproduct of using these physical properties that you don't use chemicals, you don't use chemical processes, and hence the chemical footprints, the environmental footprints of these processes is very, very tiny.
I see, sir. So, how does the life cycle of an EV battery influence the efficiency and feasibility of the recycling?
It largely doesn't. So, how do I explain this? If an atom of lithium is in a battery, it's not gonna go anywhere. It might change forms, it might change crystal structure, it might change microstructures. It's gonna be there.
Okay, sir. And what do you think are the technological advancements that are being made to improve the efficiency of these battery recycling processes and products?
Well, in hydrometallurgy, you have so many factors involved and so many chemicals involved that there are always efficiencies to be found. Um, some local areas have a lot of sulfuric acid, so you prefer sulfuric acids over there, especially when you are associated with some of these copper extraction mines or in traditional industrial areas. On the other hand, some industrial area have a lot of energy available. Some industrial area have a lot of citric acid available because there is a nature over there. So, largely speaking, because of supply chain, you can always optimize and increase the efficiency of these recycling processes to just overall general improvement of things. Also, in last 5-10 years, the volume that needed to be recycled has grown drastically. So this is largely the first time we are truly seeing these processes to be tested at an industrial scale. So there are a lot of just growing up pains, which are there and leading to more efficiency and more betterment of these processes. It's the same recipe with different flavors. It's the same food with different combination of recipes. It's still hydrometallurgy. It's not going to change its nature and fundamental sciences.
Right. So, what are the economic incentives for companies to invest in EV recycling?
Um, so largely government has been very supportive of recycling, both from a environmental perspective, because you don't want these batteries to go to landfill. So there's a very much need of these materials to be recycled. Second, from a circular economy perspective, cobalt, nickel, lithium are not your run-of-the-mill metals. They don't have that large of a footprint on earth crust or mine or industrial scale like iron or copper or aluminum. Most of the world cobalt comes from one or two nations. Actually, 80% of the world cobalt comes from Congo. So there's a true need of circular economy over there in these metals, just from the resource efficiency perspective and your national security perspective. So government has been very supportive of this. Now, from the incentives perspective, they also everybody's trying to figure out what's the best way to do it. EPR is a one very good idea whose implementation is largely being done by the industry right now. I'm a technology guy. We have largely been now to explore into the incentives of the government. So people within the policy background will be far better to answer this question because they will have a very helicopter view of things. On the other hand, we have men on the ground.
You know the grassroots level of. And so, what do you think? How can public awareness and education about EV battery recycling be improved?
So I have a very strong view when it comes to these kind of things. Good industrial engineering, you don't largely have to do a lot of PR. When you come to, if you have a old copper pan or a stainless cast iron pan, or you have old copper wires, you know that there's a guy who will come and take it from you. You don't worry about the circular economy of these metals. On the other hand, you really worry about e-waste or your Coke bottles or your plastic bags. My opinion is that the processes of recycling and the whole ecosystem of recycling should be efficient enough that the end consumer or the user don't have to worry about it. That means from the public PR perspective or from the awareness perspective, if you have to do a lot of work, there's something else that you need to fix. I would still go on the side of the industrialization and the industrialists to figure out better ways of the recycling so that the public don't have to do a lot of work.
Okay.
Because it's our job to make systems good enough that we don't have to worry about it too much. But from the EV battery recycling perspective is what we are thinking or some others thinking is that the OEM has the responsibility. You go to a service station when you get your batteries changed, they will take a battery back. Now, how the financial will be structured, how the supply chain will be structured, how the regulations will be structured, how will you be incentivized about it. There are a lot of ideas and experiments in the world that are currently going on. But like any industry that is going under transformation, it will take some time for these things to solidify.
Right. So,
But in a nutshell, the more work you have to do, the more work we have to do. If we have to ask it to do a lot of work for us, that means there's a lot of work at our end.
fair enough, sir. So, what is the role of innovation in overcoming the current limitations of EV battery recycling?
I mean, all innovations are welcome. Technological innovations anywhere are always helpful. Be it logistics, be it your BMS, Second Life, even at recycling. Anywhere there betterment can be found, it's always welcome. Pinpointing one innovation is like saying which fractal will work the best. We don't know. These things has to be tested. There has to be a series of innovations. Some of them are gonna go at industrial scale. Any innovation is welcome.
I see, sir. So, what is the global capacity for EV battery recycling and how does it need to grow to meet the future demand?
I think it's a bit skewed towards food processing. On the other hand, refining capacity is still limited. But these are the questions where the public policy guy, people with helicopter views will have far better ideas than us.
Right.
You will Google or talk to Niti Aayog, they will have pages of report on these things. We also refer those reports.
So I'm done with the questions, sir. Thank you for taking time out and talking with us, letting us have this interview.
Thank you for having me.